Hi, my name is Paul Neale, and this is a mechanical rigging tutorial we're going to be working on. And we have several parts to it. I'm going to start with setting up some simple gear systems and dealing with how to have one driving many others so that you don't have to hand animate all of them. Also, a simple way to be able to set up some basic gears as far as a modeling process goes. Just to get them started so you have something to work with. What you see here is a gear currently playing back, and it is playing back being driven by the smaller gear in front of us here, so the small one. So what we'll do is we'll start a new file, and we'll work on building a new gear and then setting it up and wiring together the gears so that they function together. Let me just do a reset. And we're going to work in the top viewport for now. Oops. And what we're going to do is we're going to create just a chamfer cylinder. And we're going to create it with a radius of 10 and a little bit of chamfer on the edge just to clean it up. So if we take a look at this, and with the wire on, we've got the basic structure to it. Now what we're going to work with is one that has 9 teeth. That means we're going to start with 18 sides, and we're going to have a tooth basically every other spacing, and you'll see the way we're going to create those. So starting with this basic structure, I think my height needs maybe just be a tad lower, make it a little bit thinner, and I'll just work on the fillet a little bit, make it a bit smaller. So what we're going to do is we're going to start with this basic structure here, and we're going to hook everything up to it and try and make it very simple to be able to propagate new gears, make new gears faster, and have them automatically meshing and working together with one another with very little changes to them. What I'm going to do is I'm going to start with this. This is going to be our gear body and our base of our gear. I'll just make that a blue color. And I'm going to go Control V and say copy, and make a copy of that chamfer cylinder. And then I'm just going to collapse that down to an editable poly, this new one. Now what we want to do is we want to work with essentially one of the faces here. So and there it is, editable poly. I don't know why it changed. There we go. So we're going to pick one of the faces, and we're going to build a gear tooth out of this one face. So with Control I and hit delete, I'll get rid of all the others so that I have just one face to work with. I'm actually going to push this back into the model a little bit, and so we can see what we're doing. I'll just turn off the display. And we also need to make the gear a little bit wider, because when the gears start to mesh, a gear tooth is actually shaped and curved going up to the top. And that makes them mesh together easier. Of course, there's all kinds of different gears, but we're going to work with this one particularly. So essentially the in between the teeth needs to be the same width as the top of the tooth. So we're going to be able to make this a little bit wider to start with. Probably about 25% on either side more, so that might work. And then what we're going to do is we're going to extrude this out, and we're just going to go ahead and just do a straight up extrude, and I'll scale it and work with it. So we'll scale it in and taper it in at the top. I think I'll taper it down a little bit so it's tapered down. I'm just going to grab all of it and maybe just taper it in a bit more too. And then we're going to curve the sides a bit, so changing over to edge mode, I'm just going to do a connect, and let's curve the sides as they would be. We're just going to do again a pretty quick one here. Obviously the accuracy that you might need may change on any given project. So we'll do something that looks like this, and we could also clean it up as well by picking and choosing some edges. And again, what's great in 2011 is the ability to be able to select and then shift select an edge, and it'll pick the entire ring. I'm just going to pick all those, and I'm just going to do a quick chamfer and chamfer that out and make it look like a pretty nice looking tooth. And what we want to do then is find out what that's going to look like when it's propagated around this model. So we have our center point, and what we can do is we can turn on angle snap so that we can snap it to given locations. What I'm going to do is I'm going to rotate it over 40 degrees around the Z, and so that it lines up. I'm going to choose instance, and we're going to need 9 gears in total, so we already have our original 1, and so I'm going to need 8 more. So there's our gears that we have, and you can see that I probably not going to fit them together very well here. So this is where I go about just doing some quick adjustments on it and making it work a bit better. Make sure it all will fit together properly. So we'll try it about there. Again, as accurate as you need to be for any given project that you're doing. If you're doing mechanical visualizations, well, you probably have some very accurate gears already modeled. So now that we have a gear, what we want to do is we want to make sure that we can actually change this up as fast as possible. So let's set the gear up so that we can change it up as quickly as possible without having to do a lot of extra work. I'm just going to delete all those extras real quick and set up one. First off, I'm going to link it up to the gear body so that when I move and rotate the gear, the teeth will move with it. And then what I'm going to do is I'm going to apply an Xform modifier onto the gear tooth. Idea is I want to be able to drive this gear tooth out when I change the radius, and so that they all stay spaced apart. I don't want to move the pivot, however. I want the pivot of this object to stay in the same place because I want to be able to propagate it around and add more teeth just based on the original pivot where it is. If I move the object in and out, that pivot's changing, and I won't be able to rotate it around and array it around the original hub of it very easily. So what we're going to do is we're going to do it with an Xform modifier, and we're going to use the radius to be able to manage that. Now it looks like I put the radius for some reason at 10.12 and forgot to type in 10. So we'll work with that. So what we want to do is Alt 5 and open up our parameter wiring dialog. We're going to load the driver, and that's going to be the radius value here. So that's going to be the driving value. On the other side, we're going to load up the tooth that we have, and we're going to load up the Xform modifier, and we're going to go find the position, and it's going to be the position out along the local, so it's going to be the Y. So I can connect those up, and you'll find that it goes firing off and gets moved away because the radius currently is 10.12. So we can just say minus 10.12, and you'll see it sits on it now. So now if I go in and change the radius, it should set it up exactly where we want it. So let's just say 10. So exactly where we want it here. And that tooth will now move itself away as we change up the radius. I've never found a really good way in sort of standard max for upping the array amount based on any given values. So we're just going to have to add our new teeth as we work with our gears and develop our gears. But again, what's nice is now that I actually have the gears, I can actually make new ones here. So I'll just do that array process again, the value of 8, and watch what happens now when I change the radius. Those teeth move in and out. Now, of course, we're going to have to set up gears with the correct amount of teeth on them, because as I change the radius, we obviously are increasing the space between the teeth, and we need to then take that into account. So as our standard gear here, what we want to do is we want to freeze transforms with an Alt right click, freeze transform, so that we have a list controller on it, and we have a 0 rotation in case it's starting in some location, a rotation that isn't zeroed out. And with a double click, we can select all of the gear, of course, and we can then propagate it out and see that it fits together reasonably well. I'm going to say copy in this case, and you can see that it fits together quite well. And it'd be very easy to mesh these two gears together because it's simply a one-to-one. And so let's just do that first and work with it from there. Again, back to the wire param dialog, so Alt 5 on the keyboard. Load up the driver, and this time we want the rotation around the z-axis. Load up the one that's going to be driven. It's around the same axis. Oops. Set our flow so that the driver drives the driven basically, and say connect. And you'll notice now that what we have is we have two gears going in the same direction. I'll just stick a negative sign in front. And you can see that they mesh correctly now. Now the way we actually deal with gears that are different sizes is a little bit different. So let's take our gear now and try and get a secondary one working that's a different size. So I'm going to take the gear out. I'll just move it over to the side here. Close my pram wires. And I want to change the radius of the gear to 20. I keep having all kinds of things happen. While the recording's happening, sorry, it seems to have some sort of strange lag. And it looks like we need double the amount of teeth, so I'm going to double click and then alt click to remove them. Make sure my pivot point is in the center using our pivot point here. Okay, so we can use that one. And what I'd probably be better off with is view and the center point. And then I'll change up the amount. And what I'll do is I'll actually increase this to 36 as well. And this gear should also now be able to mesh in with the original. And so it's going to be able to mesh in and rotate with it. Now, of course, we have the problem that when I rotate this, it's going to have to rotate at a different rate. And just doing a simple wire isn't going to be able to get us there. I'm just going to freeze transform again, just to make sure I've got zeros wherever I've placed it. And so to make this new one work, this new larger gear, what we have to know is the amount of teeth. And the amount of teeth is basically the only good way that you can actually figure out how it's going to merge together. So you have to have built your teeth correctly, and they have to be able to mesh together and be the same sizes. The pitch diameter can be used, but the pitch diameter is something that really can't be calculated. And it's a point where the teeth mesh together, and every gear can be different that way. But if you know the pitch diameter of two gears, you can also work it out. In this case, we're just going to use the number of teeth. So once again, we're going to load up, and we're going to load up our pram wire dialog. And we have our driver here and the axis that's going to drive it. We're going to have the driven on the other side. And it's going to be driven. And we'll say negative for now. So that we can see now that it rotates, but it's obviously going to be rotating the wrong rate. So the right rate is going to be multiplying our rotation value. And what we do is we take the number of teeth on the driver, so 9, I'm going to say 9.0 so that we get a float value. And we're going to divide that by the number of the teeth on the driven, and in this case that's 18, and just say update, and you'll now notice that it meshes together. So what we want to do is, again, just to recap, we want to take the rotation value and we want to multiply it by the number of teeth on the driver that's been divided by the number of teeth on the driven. And that'll give us that correct value to be able to get our teeth meshing together. Now this is going to be a little bit of a pain to keep opening up pram wire dialogues. We want to be able to find a faster and easy way to be able to mesh these together. So let's go one step more, and let's go to a script controller, and let's be able to mesh some gears together a little bit easier and a little bit faster without having to constantly go into our pram wires. And let's just have it set up so that we can change some values in the modify panel and have it automatically update and deal with it. So what we're going to do is we'll make a copy of one of our teeth again, one of our gears. I'm going to mesh this over on this side. Now this one's actually going to be pretty easy because it's exactly the same size again. So maybe I should actually make it the same. Let's actually make it, let's make it the same gear again. But this one we'll set up a bit differently. Say copy. I'm going to freeze transform so it no longer functions. And we're going to set this up with a little bit of a couple steps in it that is going to help us. Right now we're using our sides to determine kind of the number of teeth, and if we change that up, so half that number is the number of teeth we have, in this case 18. So if we have that number of teeth, then we know where we're at, so we can use this sides value right now to pipe it into the mathematics of it and get it to work. The only thing I've found is that with script controllers, that if I actually try and access the root values of the object I'm trying to drive, it'll cause circular dependencies. So what we want to do is we actually want to tie those sides back into a custom attribute, and we use that custom attribute, and it won't cause the circular dependency. So I'm going to add an attribute holder modifier on here, and go to animation, and we're going to go to parameter editor, and we're going to set up two different values. One of them is going to be a reverse checkbox, because sometimes we want the gear going one way, sometimes we want it going the other. So which way is it going to go? We don't have to want to be opening up script controllers every single time to put a negative sign in front of the variables to be able to invert it. We just want to be able to hit a checkbox. We also want a spinner to be able to say how many sides are we dealing with, or how many teeth are we dealing with here. So let's go with a couple of UI items here. We're going to go with a spinner, and we're going to have an integer value, and it's going to teeth count, or tooth count, I guess tooth count. Oops. So we'll go with tooth count. And we're just going to take a look at it down at the bottom here. I'm going to say align to the right, and I'll just align that over to the side a little bit. So there's our tooth count spinner. I'm going to say add. And then we're also going to need one that's going to be a Boolean value, and we're just going to go a checkbox. We're going to go reverse, and we're going to say reverse on that. I'm just going to say align to the right again, so it's over to the side. Now it looks pretty good. And let's add that. So we also have a reverse on there. So now that we have that, we can actually tie into those values so that we can help drive the final result. So in this case, instead of opening up the paramware dialog, I'm just going to make sure I do freeze transform. Again, I don't remember if I did. I found the easiest way to open up the dope sheet. And let's go and find the track that we're going to be driving, which in this case is going to be the rotation, zero Euler XYZ into the zero rotation track, right click, assign controller, float script. So with our float script, what we're going to need to do is set up a couple of variables. Never ever refer to objects by name in the expression area here. It's simply not what you want to be doing because it'll slow everything down, because it's having to search the scene for it, and there's no need for it because we actually have the ability to be able to add variables. So what we're going to add in is a reverse. Great. And let's do num teeth. I guess it could be the same, but there we go. And what we're going to do is we want to connect those up to our tracks here, the amount of our current values. So let's say assign track and find our objects. So here it is, modifiers, attribute holder, custom attribute, tooth count, and the reverse, and then we'll assign it. And let's find out what those actually return. So we can just simply do a print teeth and say evaluate, open the listener, I'll just push it off to the side, and you can see that it's putting out a value of 5 here. Let me just clear it. And if I scrub, you can see it's pumping out the value of 5. If I say print reverse, we have a false or we have a true. So we can work with a true-false statement here and be able to invert our math if we need to. So now what we want to do is we want to also hook up one more thing. We want to have it set up so that our tooth count automatically changes up the amount of segments in the actual cylinder here. So what we can do there is we can wire up again the actual sides to our tooth count. So this one should be currently at a value of 36. Now what I'm going to do is I'm going to leave the tooth count at 18, and we're just going to double it. So let's use a param wire again. Let's just connect it up to itself. So I'm going to load itself on one side, attribute holder tooth count, load it on the other side, and we're going to say modified object, chamfer cylinder, and we're looking for the value called sides. So sides, and we're going to say multiply by 2 count. So you can see that it's grayed out now, and I can change the amount of sides now by changing our tooth count. So with that, we can actually go and get our values and work out our math. So let's work the basic math out. The one more value we're going to need is rotation, and that rotation is going to be the original rotation of our animated gear, the one that's actually going to get the animation on it, and it's going to be driven, it's going to be the one that's going to drive it all. So let's add it in, and let's say track, and let's go and get the rotation track, and let's just print rot for a second. And what you'll see is it's going to print out the rotation value. If you notice, it's actually in degrees. What's interesting is if I change my expression now to rot, I should be getting the exact same rotation on this object as I do in this one. But you'll notice it's going way too fast. That's because it outputs radians. So what we're going to do is we're going to put a deg2 rad in front of our rotation, and now it should be rotating exactly the same rate. So now it's rotating the same speed at least, and so we're going to, whenever the script controllers are a bit odd that way, is they're going to output a radian value and degrees to radians, so, or need a radian value. So degrees to radians is what we're going to have to convert our degrees value to. So deg to rad, and then we're going to put our expression in here. So if you remember, our expression was pretty simple. We multiplied a couple of values together. Now one other value we might want is the original. Now if you want, you could hard code that if the original is never going to change, but if this modifier that we'd put here was on the original, then we could actually tie into it as well. I'm just not going to bother. I'm going to assume it's a hard fixed value that we know. So it's 9.0 divided by num teeth, and it's rotating at the correct rate, you can see, but unfortunately what it's going to be doing is we have no way to reverse it and change its direction at this point. So what I'm going to do is just do maybe a multiplier equals if reverse, so if reverse is true and we want to reverse it, we want to multiply by -1, then -1 else 1, and what we can do is we can multiply the whole statement by the multiplier. So now when we work with it, we can go in and we can say reverse, and I think that worked. It's going around the same direction. It's going around the opposite direction. So in this case, we don't want it reversing because it needs to mesh to the gears on the other side there. So now it's going to be very easy for us to change it up. We don't need to touch the script controller really anymore because we've set it up. So I'm just going to say close. I can get rid of the track view as well. And now here's one of the problems, that when we set it up, it didn't mesh correctly, and we're unable to rotate it. Now we're unable to rotate it because of the list controllers that are on the actual object now. The second controller is the one under rotation, is the one that actually has the script controller driving it, so it isn't allowing us to rotate it. So all we need to do is simply make the first controller active by either double clicking on it or selecting it, saying set active, and now we can offset our gears however we want. So now our gear ratios now fit together correctly, and they'll spin around as needed. It should be as easy now if I make a copy of this gear that we just worked with and copy it off. It'll be very easy to be able to go through and set it up and work with it to be able to mesh in some other ways. So I could easily drop it here, and of course it now meshes but the wrong direction. Let's just say reverse. It now meshes correctly, and we can easily propagate this one around, size it up, make it bigger, make it smaller, and obviously add new teeth to it if we have to. And it would be very, very easy for us to be able to change it and do what we need to with it. So again, we can actually go and take it. I should probably actually hook the radius into here as well. Might have been a good idea too. So let's actually make this this one larger. Now let's say 40. And with 40, we're going to need a whole lot more teeth. Probably 36 is what I'm guessing. And I think it's there. There we go. And we can now take this gear, whoops, and select, line it up with the others, and it still meshes correctly because our tooth count was setting it up and driving it correctly to begin with. So very easy now to be able to start setting up gears and working with them and making more and more of them very, very quickly. If you think about things logically and spreading things, your time out into doing some pre-set up on a rig like this, it saves a whole lot of time in the back end propagating it. I can make changes to this very fast and very simply without having to go in and change up scripts or having to remodel things too much. It's a very, very simple process here. I hope that explains some of the methods you can use for making it easy to set up gears.